G'day guys, Socket here. Today's tutorial we're going to look at amplifier gains and how to set them. But if you're new to the channel, welcome aboard. It's great to have you here and I hope you're enjoying all the car audio related content. If you're not already aware, there are two tutorial series looking at how to do a car audio tune from start to finish using the REW or Helix PC tool software. So if you are interested in learning how to tune your own car audio system, then those tutorial playlists are for you and you can find them on the channel homepage. But back to today's topic. So what is a gain knob and why do amplifiers and DSPs have them? Well, the short answer is a gain knob is an input signal adjustment controller. It increases or decreases the amplifier power output relative to the input signal. And some of you might be saying, Socket, what the hell are you talking about? Well, let's break it down and I hope it will make a bit of sense. So first of all, the gain knob does not magically make your amplifier more powerful. So if your amp is a 300 watt amplifier, it's still going to be a 300 watt amplifier no matter where you set the gain knob. What the gain knob is doing though is it's kind of adjusting how much input signal the amp uses to make full power or hit maximum volume. So let me explain. So your amplifier's minimum and maximum output or volume can be represented by the blue area. So when you turn the knob up to say 90%, the amplifier is at full output and your speakers are at full volume, right? But if you turn your gains up, it doesn't change the minimum and maximum that your amplifier can put out. It simply changes how far you need to turn the volume knob before you hit that 100% maximum output. So for example, in this example over here, let's say you turn your volume knob up to 70% and now you're hitting maximum, whereas before you had to turn it up to 90% to hit the maximum. And that's why it sounds louder and why people confuse the gain knob for a volume knob. But the danger is that if you turn it up beyond this point and over here, then you're at risk of overdriving the amp and causing distortion and clipping. Right? So, and the same is true when you turn the amplifier gains down. Now you need to turn the volume knob up higher just to reach your normal listening levels. So you might have to turn your volume knob up to 75% to listen to the system at a level you enjoy. So gain setting is about finding the point where both the input signal and the amp output is matched, so that the input signal, for example, is 50%, then the amp output is also 50%. So that's what a gain knob does, and to understand how it works and how to set the gains correctly, we need to dive into how an amplifier works. But I'm not going to go into too much details about amplifiers and the different types and things like that. That's all covered in the amplifier tutorial series. I'm going to keep things super simple and just talk about the gain structure in amplifiers and how the input signal is amplified and set out to your speakers, right? And so to understand all of that stuff, we need to start by looking at the signal chain. Alright, so the signal chain begins with some sort of source, like a phone or a head unit or a digital audio player or whatever you're using to make music, right? And now the signal coming out of your phone or your head unit or whatever is called an output signal, or it's an output from your source. And then if you're sending that signal to a DSP or an amplifier, it's becomes an input signal. So I'm just going to call it an input signal just to keep things nice and simple. But basically the input signals coming out of your source units are usually too weak to physically drive or move your speakers, and so it doesn't have enough volts or current that can move your speaker physically in and out. And so for that we need an amplifier. And as the name suggests, an amplifier amplifies the input signal and to a level that can drive your speakers. So for example, and I'm just making these numbers up for the moment, but let's say your input signal is at 2 volts and you put it into your amplifier, and your amplifier then amplifies that signal to 28 volts, which is enough to power your speakers and make them produce, let's say, 90 dB of sound, right? And so that's basically how the signal chain works and the role of an amplifier in that signal chain. So some of you might be thinking, well, Socket, I've got a head unit and I run all of my speakers off it. I don't have a standalone amplifier. What's going on there? And yes, you're absolutely right. Some head units have built-in amplifiers that might be putting out 30 or 40 watts per channel, or in the more expensive versions, maybe 100 watts, plus per channel, something like that. But they're generally self-contained units, and you generally can't change the gain settings and things like that on it. And I'm not really going to get into self-contained amplification systems in this tutorial. I'm really just going to stick to those standalone amps and DSP amp combos that you find in many SQ builds. And so I guess the next question is, how does an amplifier amplify an input signal, and what has that got to do with the gain settings? Well, I'm glad you asked. Let's go take a look. Well, the power an amplifier produces to drive the speakers comes from its power rails or voltage rails. Now, they come in different types. There are single rails, dual rails, and variable voltage formats, like you find in a Class H amp. But just to keep things nice and simple, we're going to look at how a dual rail standalone amplifier works. Okay, so a dual rail amplifier has two voltage rails, a positive rail and a negative rail. And depending on your amp, these rails could be 15 volts or 20 volts or 30 volts or whatever voltage your brand of amplifier has been fitted with. Now, ignoring how many amps your amplifier can handle for a moment, the maximum voltage that these rails can supply will determine the maximum power that your amplifier can produce. So for example, let's say that your amp can handle 30 amps of current, right? So now we can work out what the maximum power that your amplifier can produce by looking at the maximum voltage of your voltage rails and the maximum amperage that your amplifier can handle, right? And so the formula is volts times amps equals power. So in this case, we're taking 30 volts multiplied by 30 amps, which will give us 900 watts of what we call peak power. But let's just park this for the moment and we'll come back to it a little bit later. So as we looked at before, the job of our amplifier is to take a weak input signal from our source and amplify it to a level with strong enough to power our speakers. And the way it does that is to take power from the voltage rails and send it to the output section of the amp in a pattern that matches the input section. Right, so let's say we have an input coming from, I don't know, a head unit or something, an input signal. And so what happened is the amplifier is reading that signal and amplifying, the ups and downs or the peaks and troughs to replicate that signal as it sends it to the speakers, right? And so the way it controls the speakers is, where it has a positive voltage, it will push the cone of the speaker out, and where it has a negative voltage, it will pull the cone of the speaker in, and so by copying the input signal and amplifying the voltage that it's reading, we're able to push and pull the speaker out in a way that replicates the music that is being played by the head unit or our phone or whatever source that we have selected. So let me explain that in a little more detail. Okay, so let's say we have an input signal coming in from something like a head unit, and it has a input signal of a maximum of 2 volts. So let's say the input signal coming into the amplifier is at 0.5 volts, or 1/4 or 25% of the input signal's maximum, right? So what the amplifier will be doing is going, oh, it's coming in at 1/4 of its maximum voltage, therefore I'm going to apply 1/4 of my maximum rail voltage to this part of the signal and amplify it from 1/2 volt to 7.5 volts, or 25% of my rail voltage, which is 30 volts, right? Kind of like that. And so, for example, if the input signal then goes up to 1 volt, or 50% of its maximum, the amplifier will apply 50% of its rail voltage, to that point in the signal, input signal, right? And so it's amplifying it from 1 volt to 15, or 50% of its 30 volt max, right? Makes sense? And then let's say the input voltage goes from 1 volt to 1.5 volts, which is now 75% of its maximum. As you can guess, the amplifier will will amplify that part of the signal to 75% of its maximum voltage, right? And so it'll be amplifying it from 1.5 volts to 22 volts. Now, I'm really simplifying this down, guys. In reality, there's a lot more going on, but just to try to keep it simple and to explain the basic concept of, how the amplifier takes the I guess the percentage of the input signals, or the ratio of the input signal, and converts it into, amplifies it into higher voltages based on its voltage rails. This is not exactly how it works, but it's close enough to explain the basic concept. So when the gain is set correctly, the input signal is adjusted so it's working within the limits of the voltage rail, right? And the maximum peak might be at 28 volts, which is just below the 30 volt maximum, so everything's working the way it should, and, happy days, right? But when we set the gain too low, the input signal, kind of hugs the zero line. Your maximum peak might be at, 15 volts or something like that. And, while there's no real problem in running the amp like this, we're really not using the amplifier to its full potential. And if we turn the gains up too high, then we run the risk of the peaks exceeding the maximum voltage that the amplifier can provide. And when that happens, the signal becomes what we call clipped. So clipping occurs when the signal exceeds the maximum voltage rail that your amplifier can provide. So for example, let's say that this particular peak wants 38 volts to replicate it, but the amp can't do that because it can only supply a maximum of 30 volts. Right? So what happens is the amp does its best, the best it can, but because it can only put out 30 volts, these peaks or the rest of this signal in grey is kind of missing, right? And we end up with a clipped and distorted signal going to the speakers. But what is clipping and why is it a problem? Well, clipping basically introduces a bunch of harmonics or extra energy to the signal that isn't really there. And a lot of that extra energy and harmonics is concentrated in the upper levels of the frequency range, from 2,500 hertz and above, right, which is where your tweeters are operating, and your tweeters are very sensitive. And so when you send them or a bunch of extra energy that is not in the music, it can cause damage or actually blow your tweeters, right? And not only that, but when you think about it, your amplifier is now operating, at a much higher power level because it's, constantly, hitting this peak voltage that it's having to produce, and so it's using more power, it's generating more heat, and that leads to heat stress, overheating issues, and could potentially damage your amplifier, right? So when setting gains, we want to find that sweet spot when 2 volts or 100% of the input signal is 100% of the amp's maximum rail voltage. Well, backed off a little bit to give a few volts of safety margin, which is why when you watch videos of people setting their gains, they will turn up the gain to the point where the speakers clip and then back it off a little, right, to give them that little bit of safety. So hopefully now you know why just turning up your gain knob to maximum won't make the speakers any louder. It will just cause them to clip and distort and make your speakers sound crap. So with all of that out of the way, let's talk about the different ways that people set gains. So the 4 common ways to set gains is by ear, by eye, with the multimeter, and with the oscilloscope. Now, the best and most accurate method is to use an oscilloscope because you can actually see on the screen where the amplifier output signal starts to clip, so it is by far the best method for setting gains. But not everyone has an oscilloscope or can afford to buy an oscilloscope, so I'm going to run through the other methods first, starting with using your ears. Okay, well, the first method involves using your ears to roughly set your gains. And the way it works is to play a sine tone and to increase the gain on your amp to the point where you hear the speakers clipping, and then you back off the gain to a point where the clipping stops. Now, I'm not a huge fan of this method because while some people can hear the point where the speaker clips, I am not one of those people. And secondly, there is a real danger of damaging or destroying your speakers, especially your tweeters. So this is a very risky process, and for that reason I do not recommend it. But if you like to live on the wild side, then yes, this is one way you can roughly set your gains, but as I said, do this at your own risk. Okay, well, the second method I call setting gains by eye, simply because I don't know how else to describe it. And it simply involves working out what your maximum input signal voltage coming in from your head unit or your DSP or whatever source you have your amplifier connected to, and then setting your gain knob as close as you can to that incoming voltage. And so this really only works if you have an amplifier that has the its voltage minimum and maximum on the actual gain knob. So in this case you can see this amplifier has a range from 0.2 volts to 9 volts, and so if you've got a input signal of a maximum of 4 volts, then you've kind of got a bit of a rough idea where to set the the gain knob, right? And it will just be only rough. If you have a amplifier, for example this one here, which has from 0.2 to 5 volts, and it's actually got marked on the dial where half a volt is, or 2 volts is, or 4 volts, it makes it much easier to set your gains roughly to match your input signal, right? But many amplifiers just have a minimum and maximum, and unless you can figure out what those minimum and maximum values are, then unfortunately you're out of luck, and this method really won't work for you. Okay, the third method involves using a device called a multimeter to measure the voltage that your amplifier is sending to your speakers. Now, the theory works like this. Okay, so let's say you have an amplifier that has a peak output of 300 watts, and that's hooked up to a 4 ohm speaker, and you have a head unit that supplies a 2 volt input signal when the volume is at 100%, right? So that means I can theoretically now work out what the amplifier output voltage should be on the terminals, where the speaker wires connect to the amplifier, by using the formula volts equals the square root of watts times ohms. So if we plug in all the numbers, we've got a 300 watt peak output amplifier into a 4 ohm speaker, so 300 times 4 is 1200, square root of 1200 is 34.6 volts. So that means that on my amplifier, if I have the head unit turned all the way up and it's sending a 2 volt signal to my amplifier, if I adjust my gain to get to 34.6 volts, which is what the amplifier should be putting out when it's at its maximum, supplying into a 4 ohm speaker, then theory goes, if I adjust my gains to get that voltage, then I have my gain set correctly, right? So the way this kind of works is, so you're going to play a sine tone through the head unit at maximum volume, and then you need to turn your multimeter onto AC voltage. Now AC voltage is this little voltage sign with this little squiggle. Now you can tell the difference between alternating current and direct current. So alternating current is with the current is flowing in one direction, and then the polarity change and the current flows back in the other direction, like we have with electricity flowing to our speakers. And direct current is where the electrical current is just flowing around the circuit in one direction. That's direct current. So the two little symbols are this wavy line for alternating current and these straight lines for direct current. Look, that's just a little tip if you weren't too sure how to tell the difference on your multimeter about what settings are for alternating current and which settings are for direct current. So anyway, I'm getting a little bit off track. So you want to set it for voltage, with the alternating current symbol, which looks like this little wavy line, right? So once you've got your multimeter set up, what you want to do is then with a sine wave tone playing, you can then use the probes, the positive and negative probes from your multimeter, and connect them to the positive and negative output terminals on your amplifier, and then you can simply turn up or down the gain knob until the reading on the multimeter matches your target voltage, which we calculated to be 34.6, right? So so the steps are kind of this. You work out your target voltage, you mute all of your speakers. You don't want a signal playing through all of your speakers, and causing, at maximum volume and causing, some problems. So mute all your speakers, disconnect the speaker wires from the amplifier that you're setting the gains on. Play a sine tone, so that's 60 Hertz for subs and mid basses and 1000 Hertz for mids and tweeters. Turn up your head unit or whatever source that you're using, up to 80-90% of volume, whatever it is. Measure the AC voltage of the amplifier output terminal, so put the positive and negative probes from the multimeter on those output terminals on the amplifier where you would normally connect your speaker wires, and then adjust your gain knob until the voltage matches your target voltage, right? That's the basic process for doing your gain setting using a multimeter. Now, I've got to say that once again, I don't personally like this method because I don't think it's very accurate. It relies on you knowing what the peak output of your amplifier is. So, while they put 900 watts peak, in the technical specifications, what the manufacturer or the marketing people claim is often quite different to what the amplifier can actually put out. So it's often difficult to know just by reading the specification sheet exactly what your amplifier peak power is. But we're using this to calculate and set our gains. So the second problem is that this calculation also relies on you knowing what your resistance or summed impedance of all your speakers plugged into the amplifier is. And the problem is when you're playing music or something, speaker impedance is not fixed at, for example, 4 ohms. It goes up and down, it changes as you play music. So once again, we don't take that variability into account when we're setting gains this way. And what do you do when you're running more than one speaker on an amp, or you have your speakers, wired to reduce their impedance, and and a bunch of other, problems. But once again, it's a very popular method, but in my opinion, it's not the ideal way of setting gains. Okay, the fourth and final method for setting gains is using an oscilloscope. Now, in my opinion, this is the most accurate way of setting gains because you can see exactly when the output of the amplifier is clipping and when it's not. Now, you don't need an expensive oscilloscope. A cheap portable one from eBay, Amazon, AliExpress, or wherever is perfectly fine. I use a brand called K-Moon. The model is KKM828, which I think I bought from Amazon for like $50, a couple of years back. But honestly, it really doesn't matter what make or model you use. They all work the same. But for the number of times that you're going to use an oscilloscope, you are much better off trying to borrow one from somebody who has one than actually buying one. I think, in the couple of years I've had mine, I maybe used it twice, maybe 3 times. So this is not going to be a high use item that you're going to be reaching for and using, all the time. Okay, so the method for setting gains with an oscilloscope is very similar to the method that we use with the multimeter. So first of all, you want to mute all speakers in your system so you don't accidentally send a 60 Hertz tone at full volume to speakers that you're not going to be using, and then you want to disconnect the speaker wires from the amplifiers that you're setting the gains on. Next, you want to play a sine tone at 60 Hertz for your subs and mid bass, or 1000 Hertz for your mids and tweeters. You want to turn up your source head unit, your phone, whatever it is that you're using as a source unit to its maximum volume. Then you wanted to attach the oscilloscope probes to the amplifier outputs. That's where you had your speaker wires connected. And then adjust the oscilloscope controls until you can see that the signal or the sine tone, which looks like that wavy line. And then you can adjust the gain knob up and down until you can see the signal clipping, right? And when I mean the signal clipping, it's got the tops of the peaks sort of cut off and you end up with a flat top. When you start seeing that, you can back the gain knob off until the signal returns to its normal shape and is no longer clipping. And when you get to that point, you can disconnect everything because your gains are set. Okay, now some tricks and tips in relation to amp gain setting, and I guess the first one should be pretty obvious, but you should do your gain setting on your amplifiers before you tune your system. That's unless of course you're running all of your speakers through one amplifier, and then I guess it probably doesn't matter too much. But of course if you go and change the gains on your amps, if you've already got a car audio tune in place, it's going to change all the levels relative to each other in your speakers. So you probably need to go back and retune your system, or at least make some tweaks depending on how dramatic you've changed the gain settings. The next tip is about the volume that you play when you are playing the sine tone signal. And this really relates to head units more than telephones or your audio players, right? So some head units will distort their output when they're turned up to 100% when they're operating at their absolute peak. And so to avoid that, it's often better just to come back a little bit on the volume knob and maybe play it at 85 or 90% of its volume as opposed to 100%, so you can avoid that distortion in your signal. Now the third tip is a bit of a generalized one. If you can hear hissing when nothing is playing, then it probably means your gains are turned up too loud, and you need to turn those gains down to get rid of that hiss. So the hiss is basically noise floor that you can hear through your system, and as I said, it's an indication that your gains are set way too high. But of course it's not, gains are not the only source of hissing. There could be electrical interference and other things going on, but 99% of the time it's related to gain setting. The next tip is just a general one once again. So there's nothing wrong with running your gains a little bit lower than absolutely maxing them out. So for example, if we're using the oscilloscope and we get it to the point where it clips and we back it off a little bit to give us a little bit of a safety margin, there's nothing wrong with backing it off a little bit more just to give you a bit of extra wriggle room, because certain tracks and certain artists or whatever can have super high peaks, and just backing it off a little bit not only lets your amps run a little bit cooler, but it also gives you a little bit more of a safety margin for whatever style of music that you happen to be playing. The next tip is around bass boosters, EQ and other special effects, things that you have either on your phone or your digital players or set up in your head units. Now if you're the type of person that likes these special effects and bass boosters turned on, then my suggestion is to have them turned on when you are doing your gain settings. If you turn them on after you do your gain settings, what they do is actually boost the volume levels or your input signal, and can actually put you into above your rail voltage and into this clipping zone, right? So yeah, just a bit of a tip about those types of features. The next one is a little bit more complicated. It's how do you deal with systems where you use multiple sources for your music, or you have multiple amps in your system? Well, yes, it gets a lot more complicated. So let's talk about each of these things in turn. So what I mean by multiple sources is sometimes you might use your head unit, sometimes you might use your mobile phone to stream music, and sometimes when you switch between one or the other, you'll notice that the volume of your system goes up or down, and that's because each of these sources have a different input voltage or input level. So what you want to do if you are using multiple sources is pick the one that has the highest level, and use that as your source to set your gains. Now if you have multiple amps in your system, essentially what you'll need to do is set the gain for each of your amplifiers in turn. And as I said earlier, once you've done that, you'll probably find that you'll need to retune your system, because if you have an amp that's running your mid-range, for example, and another amp running your mids and your tweeters, now all of a sudden you've changed the gains on those amplifiers. They're no longer going to be level matched. And we talked about potentially doing your gain setting before you tune your system, right up on kind of 0.1. Now the final thing is, or the final tip is, how do you know when everything is dialed in just right? And this is a bit of a generalization, but I hear this in lots and lots of cars. When you are in a car where it's not clipping and where you have very low distortion, and I know that distortion is not exactly related to amplifiers and gains. There's a whole bunch of other things, but certainly having your gain set too high will lead to more distortion in your system. So when you are in a car that is distortion free, you can turn that system up super loud, and it's clean and it's crisp, and it's really easy to listen to. And in fact, sometimes you don't even know that it's turned up really loud, because it's so clean that when you go to speak and you realize that you can't hear yourself speak because you can't hear yourself over the system, that's when you know that you're in a distortion free car, and you have got everything dialed in right. Now what I hear in a lot of systems is a lot of distortion, right? Particularly when people turn it up super loud. At low volumes it's clean and crisp, but when they start to turn it out, the system starts to struggle and it starts to fall apart. The sound sounds harsh. It's quite shrill in the upper levels. It's quite fatiguing. It can be smeared or blurry, and it's just unpleasant to listen to. It's kind of like when you sort of squint or screw up your nose, because it's so loud it hurts to actually listen to. Now if you're in that type of listening to that type of system, it's because there's a lot of distortion that's causing all of those problems. And as I said, distortion is not exactly related to gains, but certainly will get worse when your gains are turned up. So there you go, guys. I hope that's cleared up some of the mystery around what the gain knob is for, and how gain and amplifiers work, and most importantly how to set the gains on your amplifiers. So that brings us to the end of today's tutorial. As always, thank you so much for watching. If you've got any comments or questions, feel free to throw them down in the comments below. I'll try to get back to you as quick as I can. Otherwise, guys, thanks again, and I will catch you in the next episode.